In this video, I shall show you how to use CAP697 to obtain the endurance for our multi-engine piston aeroplane, or MEP1. We shall be using figure 3.5 to show you how to do this. This is figure 3.5, and just like all the other tables and charts, in the CAP697, there is a worked example with a solution. We will not be using the worked example, we will be using our own numbers so that you have another example that you can fall back on or practice. And you can of course check your answer against the solution to make sure that you've executed the correct technique. This chart looks very similar to figure 3.2, MEP range. So don't get mixed up between these two charts. Endurance is for time, range is for distance. In our example, we will assume that we are going to cruise at 10,000 feet. So we will simply draw a line across the chart at 10,000 feet. And that should look something like this. Next, we decide if we want our endurance with our reserves intact, which we will use this side of the chart, or if we want the endurance with no reserves remaining, and that's this side of the table. And the last step is simply to determine for your power setting what is the appropriate endurance. Let's say we want to cruise at 65% power, so we will simply select the 65% power line. You can see we have 75, 65, 55, and 45. So at 65% power, we just need to draw a straight line down to the endurance scale and read off the scale. Let's do that now. And that should look something like this. So we simply read off the endurance scale, and the endurance scale is given in hours. So that's 5 hours. We're a little bit below 4.5 hours, so something like 4.45 hours. So our endurance is 4.45 hours with 45 minutes reserve at 45% power. And what that means is that we can fly 4 hours and 27 minutes. And after we have flown 4 hours and 27 minutes at 65% power, we can fly an additional 45 minutes with 45% power. Remember that reserves are always flown to extend endurance or range, and the power setting at which we will do that for the multi-engine piston is at long-range cruise or 45% power. So regardless of the initial power setting, the reserve will always be flown at 45% power. Now, should we want to find the endurance with no reserves intact, then we simply move over to the right hand side of the chart, and for the power setting that we have chosen to fly the aeroplane, we simply go down the chart and again read off endurance. This endurance will be the endurance with no reserves intact, which means at whatever time the endurance runs out, the aeroplane will have no more fuel left. Let's try that for 65% power. And at 65% power with no reserves remaining, we would be able to fly a total of 5 hours exactly. And this is how we use figure 3.5 endurance for our multi-engine piston aeroplane.